Hello and welcome back to the channel. In today's video, we have an exciting and interesting project to work on together. AWS Spark Unstructured Data Streaming. I know you are probably familiar with structured streaming, where you have the rows and columns properly defined in your data set. But how do you work with data that is moving and dynamic, where the position of the data is not properly fixed? Now, in this case, you are looking at something like text, image, PDF, audios, and videos as well. How do you handle this kind of data in your data lake system? Now, in today's video, we are going to be answering all of these questions. We're going to start by reading the text format systems, where you have the data that is not in a fixed position. So you have to search where the data is going to be and structure it in the right place. All right. And this is going to cater for multiple data sets, whether the data set that you have is a text file, JSON, PDF, audio, video, or even CSV. Now, this kind of data sets are going to be more generic, and the way you are going to handle them needs to be way versatile and generic as well. Now, before we continue, we are going to go on into the architecture section shortly. But before we do that, if this is your first time and you have not subscribed to the channel, don't forget to like and subscribe to the channel right now so you don't miss out on any amazing content and you also stay up to date. Now, let's go on to the architecture section where we discuss the intricacies of the system we're going to be building today and how each of the bits and pieces are connected together and how we develop the system from end to end and from start to finish. So let's go on to the architecture section and discuss that. This is the architecture of the system we are building today. We are going to start by having data that are coming in form of text, CSV, image, video, PDF, and as well as JSON. All of these data are going to be connected to our client, which is going to be a Spark streaming client. Now, as these data are dropping into a specific location, our Spark streams are going to be picking them up, submitting them to our Spark master worker cluster. And once the data is submitted, it's going to be streamed directly into AWS S3 bucket. Eventually, once we are satisfied with the number of records and data that we have, we are going to have a scheduler or a crawler on AWS Glue that is listening for all these changes in a scheduled pattern, maybe every 1 hour, daily, or something like that, that is scheduled to do that. It's going to create a table for us, load the data into this table and the data catalog. So a database and the table will be created for all of this data into a single table that are being created for us. Eventually, we are going to use Amazon Athena to visualize the data that is on our data catalog. And eventually, if we have enough time, we're going to have Amazon Redshift connecting to our data catalog. At the same time, we can connect our visualization, whether Plotly, Power BI, Tableau, or Looker Studio. Eventually, all of these are going to be connected together, and you can see how the data streams from our source system, which are all of these data that are being generated from here up to the end. You are probably thinking, but JSON is a structured format. Yes, it is. CSV is also structured as well. Yes, it is. But TXT, PNG, PDF, image, audios and videos are not structured. How do you read them? And in some cases, you have a mixture of all these systems where you have structured systems as well as unstructured data, rather. You have structured data as well as unstructured data in your system. How do you handle them and extract information reliably from all of these systems combined together? These are the kind of questions we are going to be answering in this video today. So let's get into the coding section and get started. Let's get started by creating a new project. I'll call this project AWS Spark Unstructured. Okay, that will be the name of our project. Now, we are going to change the Python version from 3.11 to 3.96. For some reasons, I'm a little bit comfortable working with 3.96 because of the different modules and versions, conflicts, and all that. All right, so we are going to have a main.py welcome script, which is totally fine. So let's just click on the create button and get started with that. Okay, so PyCharm is bootstrapping our project and is getting ready to go. All right, so let's open our terminal and ensure that everything is properly installed and set up before we continue. Okay. All right, so we're going to start. The approach that I want us to take in this video is to start with a simple system, a PySpark environment, so we can just quickly do some iterations in that case. And eventually, once we are done, we focus on the architecture of the system. Then that is going to be on Docker, and then we submit our jobs on Docker, and we can visualize the processing layer in that case. But what I want us to really focus on right now is to get the system architecture right, because there will be multiple iterations that we're going to be working with. So let's continue. All right. So let's quickly set up our Spark master worker architecture. Okay, so let's get started with that. So I'm going to touch docker compose, .yaml. In our case, we are going to go into the Docker Compose and start with the version 3. So we can just quickly write our master worker architecture in this case. And I'll just disable completion for my Copilot. So I'm going to have services. And in the services, we're going to have our Spark master. The Spark master is going to be an image coming from bitnami/Spark latest. And I think I should increase the font size a little bit so it's easier to read. And we're going to have the volumes. The volumes are going to be where we are mounting into our system. For now, we just keep it at simple jobs. Nothing too serious for now. We're going to adjust this much later, but for now, let's leave it at jobs. OPT bitnami, then Spark jobs. All right. Then the command for the master, of course, as simple as this is going to be bin Spark class, and we're going to have org.apache.spark.deploy.master.master. All right. Then the ports that we're going to be working with, we're going to be exposing port 9090, of course, as our external IP, and 8080 as our internal IP. Okay. Then the same thing with 7077, which is where we are submitting jobs to both externally and internally. All right. Then the networks that we're going to be working with in our case is going to be, the network is going to be Data Mastery Lab. All right. Just space this, Data Mastery Lab. Good. And simply, we just have this as our master. Then for our worker, we have Spark Worker. For Spark Worker 1, we're going to be inheriting this from our Spark Common as usual. So if this is a little bit strange to you, we have had several videos on this architecture, and these have served us a couple of times, and it works just fine. So we just stick to that. So we have 2, 3, and then one more for 4. Good. And we have 4 workers in this case, all inheriting from Spark Common. But of course, we don't have Spark Common right now. So let's create Spark Common outside of our services. So that's going to be X Spark Common. All right. And that would be Spark Common. We have the image for that. The image is the same thing as the master, of course, bitnami, bitnami Spark latest. So in the volumes we are mounting as well, it's going to be the same volumes. It's going to be the same thing as this guy. Just copy that and I'll paste this here. Okay. Yep. Then finally, we have the command. Just copy the command and just change a couple of arguments in here. So it's going to be in Spark class, and instead of master, it's going to be worker, worker, and then we need to pass in the Spark master URL, which is where we're going to be communicating with. That will be Spark, and then Spark master 7077, isn't it? Once that is done, the final thing we need to do is get the depends on, of course, to depend, the workers should depend on the master. So that will be the Spark master. So let's set in the environment variables. So the environment in this case is going to be the Spark mode. This is going to be operating as worker. So all of them, the Spark master, Spark worker 1, 2, 3, and 4 will be operating in the Spark mode of worker. And then we have Spark worker course is going to be 2, and the Spark worker memory is going to be 1 gig. I think usually the minimum is 1 gig. So Spark master URL is Spark, and we have Spark master just like before, 7077. And then finally we have the networks. The networks in this case is going to be Data Mastery Lab. Perfect. Now, this wraps up our master worker architecture. For now, we just get this here. And if we don't have finally, we need our the network as well. So we just get in our network in here. So that would be networks is going to be Data Mastery Lab. Data Mastery Lab. Okay, good. And that would be all for our master worker architecture. And this is all we need to do, really. We don't have to do so much. So what I want us to do is just focus on the pain points in this case. According to architecture, we are not going to be focusing too much on Docker aspects or something else. It's just going to be the architecture and then how we get this unstructured data in, which is going to be through real-time streaming with Apache Spark, and then writing that to AWS S3. So if you are a follower of this channel, you will realize that in our previous videos, we have a connector that we set up in the previous videos where we connect from Spark streaming to AWS S3 bucket. That same process still applies. So I will not go too much into the details of how to do the connections and here and there. You can see the video just up there in the card section of this video, just here being suggested to you. So you can go through that video to see the details of how we do the connection and all that. I'll just quickly get the keys and all that, so to save time. All right, so let's just proceed. Okay, now that we have our environment properly set up, if we don't have our Docker, we just bring up our Docker instance. Let's bring that up. So Docker should come up. I think it's currently shut down for now. So once that is done, we have this out of the way. Opening the terminal, we just clear this up, and yeah, Docker is up. Then we just do Docker compose up in the dash mode. So if this is what's up, it says additional property depends on is not allowed in Spark Worker 3. So what's going on? Let's see. Depends on, yeah, it's not dash on, it's underscore. Yeah. Okay, and we run that again. Perfect. So everything is coming up as expected, and you can see we have 1 master and 4 workers in this case. So that's exactly what is being spin up on our AWS Spark Unstructured in our dashboard here. Everything is coming up just fine. Let's just proceed. The architecture is there, but we're not using it for now. We just minimize this and just keep it at bay for now. Now, going back to our main. So in our main, we are going to set up our environment where we are going to have PySpark to be leveraged on in this case. So let's quickly install the packages and then get in all our utils and for the complex parsing that we're going to be using for our structured data. So we get this in through in our main.py. We start with the main.py, and then let's quickly do the installation. Pip install PySpark, and once PySpark comes in to play, we have from PySpark.sql import Spark session. Okay, and excuse me, and then we have an entry point in this case. If the name is exactly equals to main, then we start with Spark, and then we get in all our configurations and all that. So that comes in equals to, then we have a Spark session dot builder, isn't it? App name. The app name in this case, capital N name is going to be AWS Spark Unstructured. Okay. Maybe I just add analysis to that, or I'll just leave it at that. Yeah, AWS Spark Unstructured. Yeah. So once this is done, we get in our configuration. So that will be config, and then we get in our jars that we're going to be using. So we have spark.jars.packages. And in our case, we have a couple of jars that we are going to be using. So one to connect to our Spark the other one to connect to AWS, really. So we are going to have org.apache.hadoop, and that would be connecting to, we're going to be using the Hadoop AWS 3.3.1. Okay. And yeah, this would be comma. So this will not have comma at the end. The comma should be inside of the code. So please be careful of that. And we're going to have Amazon AWS, and that would be using AWS Java SDK. And the SDK we're going to be using, the version is 1.11.469. So you have to be careful in this case. If you use a mismatch of these versions, you might run into issues. So I've tested this and I've seen that it works just fine for me. So I'm sticking to that. All right. So finally, we have our config, all other configurations that are going to be used. We are going to be having our spark.hadoop.fs.s3.s3a. Yeah, sorry. s3a.implementation, and that will be coming with, is going to be assigned to our org.apache.hadoop.fs.s3a.s3a file system. Okay. So this is a little bit tricky, so you have to be careful with the spellings, and just quickly get in the access key, and yeah, access.key, and this would be secret.key. So let's fix this as well. So the access key is not going to be coming from there. We're going to have a configuration file that we're going to be getting the AWS access key from. And we just do the same thing from here. We don't have a configuration yet, but we're going to set up that configuration shortly. We have AWS secret key as well. Okay, and finally, the last thing we need to do for our configuration of AWS is the credentials provider, which is the S3A. Instead of implementation, we have aws.credentials.provider. I think this is the one that helps us to know the type of provider that to use for connection. All right, we have S3A. In this case, instead of S3 file system, we're going to have simple AWS credentials provider. Just in case, you might want to look at the documentation for the specific details of how each of these connects to Apache Spark and what they are used for, because if I don't do enough justification for the explanation. All right. So, but eventually, once that is done, we get our create. Now, finally, that environment has been set up. So let's take care of this configuration. So we're going to have a config file that we're going to be using. So we're going to make directory config, and inside our config, we're going to touch config /config.py, and in our config.py, we are going to have just a couple of configurations in there just to represent our AWS information. All right, the access key and the secret key. So that will be configuration equals to AWS access key, and that would be taken care of. For now, we leave it at 3 dots, and AWS secret key is going to be 3 dots as well. So we are taking care of this much later. For now, if you have your AWS handy, AWS secret and access key handy, you can just put them there. But for now, we just leave it at that. So let's bring this in. So from config.config import configuration. All right, and that should fix this issue for us. All right, now that is fixed, the next thing we want to do is now setting our entry points where we are going to have our all these different inputs that we have. We have the text, we have the JSON, just like we have in the architecture here. We have text, CSV, images, videos, PDF, and JSON. So we're going to have different entry points for them. So let's see how that looks like in this case. All right. So we are going to go back to the code, and here we are going to have the first one, text input directory. Input directory is going to be coming from file. So let's create the directories for them. So we're going to make directory, and this will be let's say input, and we say input. We go into input and we make a call inside the directory. We have a couple of directories to create. In this case, input text. We create input JSON, input PDF, input videos, I'll say input JSON as well. Input JSON. 1, 2, 3, 4, 5. So we can also have music if that's the case. But for now, let's just keep things simple and short so we don't spend too long in this video. We have CSV as well. Yeah. Input CSV. Make directory, input CSV. Okay. So that's 6 inputs. And you can see the 5, is it? Yeah, 5 inputs here. 1, 2, 3, 4, 5, 6. One is missing. And in our case, we have txt, CSV, image. What's next? CSV, JSON, PDF, text, image. Yeah, make directory, input, image. Now, you might want to ask me, how do we plan to read all of this information? So there are a lot of packages that allows us to pass information in videos, music, MP3, and images as well, and maybe PDF if you are interested in that. But we are going to be focusing on the ones that are easily passed right now. But we have maybe a special video that can allow us to go into the details of passing videos, music, audio files, and having a real-time streaming with Apache Spark. So let's see how that goes. If we have enough time, we can cover that, but we are going to go for the ones that are low-hanging fruits, and we can quickly cover in this video. All right. Okay, so we have all of this. Good. So now let's quickly link them in this case, and we continue from there. So we have, I'll just quickly copy this part. The part in here, I'll just say our text, which is this one. I'll just copy path for reference. I'll copy that and I'll paste it in here. And that's for our part. We have a JSON input directory. We're going to have, I'll just put this as a normal string. We have CSV input directory. That would be this. We have PDF input directory. That will be this as well. And then finally, is it? Yeah, PDF. We have a video input directory. That will be this. And what else are we missing in our case? We have image input directory. Excuse me. All right. Now let's quickly get all of this in. So our JSON, we right click, copy path for reference, full path, and then file, paste that in. The same thing for CSV. Do the same, copy that, copy this, file, then we do the same for PDF. All right. Copy path of reference, and then we have file, and video, we have file, then this, and finally we have image as well. Finally, good. No way, I'm using I'm using PDF for them. Okay, so let's fix that. This will be video input video, and this will be input image. All right, img. Good. Anything else? That's all. So good. So the data is the input directory is there. So how do we proceed from here? It's interesting how we're going to proceed. So what we're going to do is we're going to be listening for file changes in these directories that we are linking to. So let's say we want to pass a simple text file. What we just have to do is drop it into this CSV, into this text directory. And what happens is our Spark streaming picks it up once it sees it and processes it into S3 bucket as it is coming in. So we see how that goes in a short while. All right, so we have this. So let's get in our data structure, the schema for the system that we're going to be building, because we are going to be needing that for our JSON as well as maybe text if we want to be strict about that. We are going to have data schema. So in our case, we're going to have struct type. By the way, this has been done in the background anyway, so I just have a struct field, have file name, and it's going to be of string type. and it could be nullable, of course. Nullable is true. I'll just replicate this a couple of times. Okay, just copy this. Yep. Okay. Excuse me. We have position. We have class code. We have salary start. We have salary end, underscore end. We have the start date. We have end date. We have the requirements. We have, no, just duplicate this a couple more times. We have requirements. We have notes. We have duties. We have selection. We have experience length, and we have job type. What else do we have? Just duplicate this a couple more times. We have education length, and school type, and application location. All right, so these are the things that we're going to be focusing on in our data schema, and I don't want it to be too much, but we can get more information if we are interested in them. For now, we just stick to these ones. I think it's pretty much straightforward once you understand how this goes and what we're going to be doing with it. So our salary end and start is going to be double type, so it's not going to be string. So we're going to change this to double. All right, double type, and the same thing will be replicated for salary start as well. Date will be, instead of string, this will be date type. All right, paste that. And I think anything else in here, yeah, th, yeah, and I think all of them have been done. So let's just bring this in. Start date. This, of course, this is going to be date. Good. So let's bring this in as well. Just imported all of that. All right, finally. So now in our CSV, JSON, or all this information, all of these things are common to all of them. But how do we get the location where they are? So let me show you an example of the structure of the CSV as well as the JSON and how they look like. Okay, so let's start with the JSON. So I have in our input JSON, so I'll say I have a JSON file in here that I have prepared, and this is how the JSON look like. So it's going to have something like this: workers' compensations claims assistant as the job description, and in this case we have a file name and all of this already prepared, so we don't have to do so much parsing in this case. Just quickly link into our data structure and the schema, and we are good to go. But in a case where we are working with something a little bit more complex, so let me show you. In our CSV, it looks like this. Just one sec. Yep, so it looks like just like this. Now this is how the CSV or the text look like. So we have the position here, the class code, the open date, which is when the position start or the job advert was made, and when it was revised, if at all. Then we have the annual salary, which starts from $44,000 to $81,000 as the maximum. So we are looking at picking up the first, which is the lower band, and the highest band in this case. So that will be the salary start and salary end. So we don't have to get this and that. Okay. Then you can see we have notes in here. We have duties, we have requirements, and of course another notes here, where to apply, another notes, application deadline, qualification review, selection process, conditions of employment, notes, notice, and all of this other information. So Now, this is all we are going to be parsing, and we are going to be putting them in a structured format at the end of the day. Now, this doesn't have to be exactly like this. So we're going to have different structures here and there. This is just a sample of what we're looking at. But in a real sense, the data is not as structured in this case. Not really structured, but not as structured in this case. So the structure changes and varies. The positioning and the data, of course, changes here and there. So we have to cater for different edge cases. We may not cater for 100% of them, but maybe 95 or 99% of them. We try to, as much as possible, cater for a large number of them. Okay, so let's start with that. So this is going to warrant us, because we are dealing with something that is so unstructured. We have to get our custom defined user defined function. So we're going to have defined UDFs in this case, where we are going to be putting all our user defined functions in there for our data parsing and all that. So let's quickly get in our defined UDFs. Okay. So I'm going to create a new file. I'll call the file, and just do that. So I'll go out of the input, I'll clear this up, and I'll say touch. I'll call this UDF utils.py. All right. So that will be here. And this is the utility functions that is going to warehouse all of our codes that we're going to be writing. So let's start with the first one. Let me just put a simple CSV so that we know exactly what we're working with in our case. All right. So I'll just put that on the side so we can just use that to correlate our user defined functions and how we're going to be working with each of them. All right. So I'll just put this here, minimize this here. So let's start with the first one. So we start with the file name. So dev extract file name. So the input is going to be, of course, file content, and usually that would be the first line in this case. So if at any point in time the data is unstructured and is moving down or anywhere else or right or left, wherever it is, we are going to get that. So we're going to be returning data here. I'll just say pass for now. So we are going to extract the file name, and then we are going to get the position as well. Dev extract position, of course, the file content. I'll pass this as well. Then what else do we need? We need the salary, we need the class code, the open date, and all that. So we have the extract. We have the position already. So we have the salary, and we have the file content. We pass this as well. Then we get in the class code, dev extract class code, and that will be file content as well. And then we pass that. Then we get the date. Yep, dev extract date, and that will be file content, and then we pass this. Okay. Let's see, what else do we need here? We need the requirements or the minimum qualifications. Okay, so dev extract requirements, which is going to be the file content as well, or the minimum qualifications. That's fine, we pass. Okay, excuse me. So we have the notes as well. Usually the process notes, you can see that here. So that will be the process notes here, 1 to 6. So we have, that's the one we want to focus on. The process note exactly is what we want to focus on, or we see the notes where you see it shortly. Extract notes. So just get the file content. We're going to see how we'll do that shortly. So I just want to get the skeleton into place, and we see how that looks like going forward. So we have the duties as well. Let's see. We have duties. Yeah, I'll get another CSV file, another TXT file here, but we have duties. So we have extract the duties. In our case, we have file content. I think it's also the same thing as requirements, but for now, let's just continue. I'm going to have, we have this, yeah, this will be the start date, and we need the end date as well. Okay, I'll just duplicate this, and then we have end dates. Okay, and date. And once that is done, we are done with that. Let's see, we have the selection, dev extract selection process, of course, file content, and we get the selection and we pass that. And we have dev extract experience length, file content, then we pass. Okay. Let's see what more we need here. We have education length as well as the application location. So we have extract education length. That would be the file content, and we pass this. Then we have the extract application location. That would be the file content as well, and we pass this as well. So let's count how many data points are we extracting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see what we have here. 2, 4, 6, 2, 4, 6, 8, 10, 12, 14, 16. So we are still a couple short. So let's see what we need. Job type, I think this is going to be coming in straight from the data directly, and education length is going to be, let's see, do we have duties in our UDF? Yeah, duties is here. Okay, notes is here, requirements, class code, end date, start dates. I think I'll just leave it at this. If we find out any other thing, we just continue and add this to that, so we don't waste too much time on this. I just want to be sure we are matching all of this as we want, really. So I think for some reasons, Docker is slowing down my system, so I'll just spin this down for now. All right. Okay, so let's continue. In our define UDFs, so let's bring this in. So we say from, where's the name again? UDF utils. Okay. From UDF utils, import asterisk. So we just import everything from there. And let's get in our UDFs. Okay, let's create a function to do that. We do that outside of this main function. Okay, so we have define UDFs, of course, the multiple user defined functions. So what I'm going to do basically is to get in a JSON that just maps into the UDFs, okay, and the data types that is going to be required in this case. All right, so we're going to have extract file name for the UDF. Okay, I'm going to have my user defined function being brought in from there, and reduce this a little bit. Then we start with the extract file name, extract file name, and we call this and give it a string type. Okay, in this case, just duplicate this a couple more times. All right, we have the file name, we have the position UDF, we have the salary UDF. We are going to have the salary is going to have a start and end. Of course, we have the date, which is the start date. We have the class code UDF. We are going to be having requirements. Then we have notes. What else do we need here? We have duties. We have end dates, and we are going to have selection, and one more thing, experience length. We are going to have education length as well, education length, and yeah. We are going to have application location. All right, so let's fix this in. Extract position. Salary. So salary is going to be a struct type that has the salary start and end, of course. So we're going to have extract salary, and instead of string type, it's going to be of struct type. And inside this struct type, we're going to have an array of struct field, and this is going to have salary start, and we have the double type, which could be null as well. It's true. Just duplicate this, capital T, yep, and capital T, yep, and salary start and end. We do the same thing for date as well. So I'll just, I think I should just duplicate this, really. Okay, extract date, UDF, date UDF, and this is going to have extract date. And we are going to have, no, I'll separate this because the function is a little bit different. So it's not together. So I'll just leave it at that. I'll say extract date, extract start date, and this will be of date type. Yeah, and this is comma. Then for the end date as well, I'll just bring this in, extract end date. All right, and this will be date type. And class code, we get in extract class code. And this is going to give us a string. We have the requirement, extract requirement, of course. Then we have extract notes, extract duties, and selection, extract selection, experience length. Yeah, what else? We have the education length. Then we have the application location. Good. And I think double type. Yeah, the rest is string. Okay, good. What's this? Dictionary object is not callable. Yeah. Extract experience length. I think everything is fine. I'll just leave it at that for now. And yeah, we should be good. What am I doing? What's going on here? This string type. Yeah. And this is I don't know what's wrong with that, but I'll just leave it at that. If there's any error that is compiled, we just or during runtime we have any error, we're going to fix that much later. But for now, let's leave it at that. Yeah, it's a little bit concerning, but I don't know what exactly is this issue is. Yeah, I'll just leave it at that for now. Yeah, I'll leave it at that. I think it's the parser issue or something like that. Just leave it at that. Okay, so let's quickly start the implementation of each of them, and we start running a simple CSV against that to see what is going on with it. All right, so let's see what we have. We have our schema in here. We have our UDFS here, and we are getting all of the UDFS here. UDFS here. So let's start with reading from the input directory, and that will be coming, the data will be coming straight from our txt file. All right, so let's see what that looks like. We have job bulletins, df. That was going to be, have a spark dot read stream, because we want to have a stream listening for events or the addition of data into this particular location. We have a text in a case, and in this case we're going to have, I'll just close this up. Okay, then we have the option we're looking at in this case is, yeah, the whole text. So what this means basically is it's going to read the entire CSV and put it into the value location of that particular data frame. So you know when you read a CSV or you read any information from the stream, it's going to have a value column where the data is going to be sitting in. So that's what exactly what we're doing. We're saying all the CSV data that you are passing, put it in the value column. All right. And we have the load. So we are loading from the input directory. Where's the our text input directory? Text input directory. Okay, good. Now, once this is done, we can easily visualize this by doing job bulletins dot show, and let's see how that looks like before we continue. All right, so I'll just copy a file from here and I'll just paste it in there. Okay, input text, and I'll just put it here, paste, and we can start. Yeah, we can just start our by running python main.py. So we just want to see, because I have PySpark installed on my machine, of course, so I can use that directly without issue. So it says, yeah, of course, we need to submit this to the gateway so we can have access to all of this, information here. So it looks like there are some resolutions that failed to download here. So to do that, we just do Spark submit, and I'll just get in all of these packages. So in our case, we are getting the SQL Kafka. I have to remove this. There is no need for this, but we need the Hadoop AWS, the Java SDK, and the faster Jackson, because on my system, I'm not submitting to the cluster, so I'm having some issues with faster Jackson. So, but that may not be the case for you. But if you want to be sure, you can add that as well. So I'll just leave it at that and submit this to our cluster. So let's see what that looks like. So that is loading up, and we should see the output being printed out. Okay, so it says UDF is not defined. And yeah, of course, because we've not started passing anything. But for now, what we're doing basically, it says UDF is not defined. And let's see why UDF is not defined in our case. Yeah, we didn't import it. So import this name from SQL functions. All right. And that should fix that for us. I want us to see how the data is being passed into our Spark system, so we know how to properly pass this data and send it to different parsers for parsing. Okay, so let's see what that looks like. It says It says file this and that. It took this to that. So it couldn't load that. Query source must be executed with right stream source. Of course. Yeah, my bad. So at the end of the day, we are going to have just quickly write that. So I'm going to have a query. It's going to be we want to print this in the console. So we're going to have job bulletins dot write stream, and we're writing, in this case, we're writing to the console. The output in this case is going to be console. So we have write stream, then the output mode in this case is going to be append. I'll just put append in this case, and we have the format is going to be console. So we're writing to the console, and we can easily say dot start, and we can say query dot await termination. Termination. Okay. All right. So what's going on here? Output mode, not output. Yeah, output mode is append, write stream, append. Good. And yeah, that's all we need to do. So let's see how that looks like and run this again. Okay, so let's see what that looks like. Yeah, something is wrong here. It says streaming sources must be executed with that, and that's exactly what we just did. but for some reasons, it's not reading that directly. What's going on? We have text input directory, input text, and this is our file source, but it's not reading that. Why? Let's see. Oh yeah, I just removed this. Okay, and I'll stop this. We can see how the data looks like in this case. You can see everything here is read into the accounting clerk. So if we want to see that without issues, we can add another option here and say option. We say truncate equals to false. So, but this is going to print all of them in the terminal, and we will see everything without break. But I think it's important for us to see that before we start parsing, because we need to know exactly where the data is sitting in and how to parse that data that is sitting in a particular location. If you don't know that, it's just going to be like a copy paste stuff, which is not what we're trying to do in this case. So let's see what the data looks like. We have yeah, I'll just leave this here. Yeah, you can see the data here, and everything is here being read in literal time, because you can see the return carriage and the new line and all that. You can see everything here is read into a single column, and that is possible because we use that old text true in this case. Good. Now we've been able to establish that. The next thing for us is to start parsing them. So how do we do that? We have a utility function for our user-defined functions that have been created. So we need to start using that utility function to start parsing each of these particular data that we need. Okay, so let's do that. So we're going to be employing something called the regular expression. So in this case, you might need to have a little bit of understanding of regular expression to be able to follow through in detail of how to do the parsing and all that. But it's not a problem if you are not so familiar with regular expression. Just try to follow along. You understand the gist of the everything we're trying to do at the end of the day, but it shouldn't be too difficult for you to follow along. But you just need to have a little bit of understanding in that case. Okay. So let's import our regular expression, RE, and then we're going to be needing the date time. So from date time, import date time, because we need to pass in the date. Okay, so let's start with the file name. So we are going to start by getting the file content. Okay, we're going to strip that. So by stripping that file content or strip, so if there's any leading spaces or leading or whatever, leading or trailing, yeah, or trailing white space, we are going to be able to trim that off, and then we're going to just get the first line, which is the position. So we say position in this case. This is the file name. It's the same thing as position, really. So I'll say the file name is going to be the file content dot split. So let's split that by the backspace, backslash, and then get the first line in this case. So we just return that. We're going to revisit this because there are some that are not structured as we want. So let's duplicate this for position as well. But for now, let's just leave this as it is. We are going to come back to this much later. All right. So now let's, this is going to get us the position, supposedly, because that's the first line in this case, accounting clerk. Okay, so let's continue with job bulletins. In this case, user-defined functions. I'll just move this here. So we have the class code. How do we extract the class code? It's not too difficult, really. So to extract that, we need to do a try catch. So try except, in this case, not try catch. Okay. So if there is no class code, we raise the value error and say error extracting class node. Okay, and this is the error. Except exception as E. Okay, good. So in our try catch, we're going to have a regular expression, a class code match. So we are going to have a regular expression in this case that searches for that. So we are searching for class code. So what are we searching for in this case? Class code. If you look at this file, we are looking for class code, this particular keyword with this full column. So that's what we're looking at. So we need that wrapped up, and we're looking at a string. Then we're going to get the D plus for that, and that gives us access to that particular class code, and that will give us the file content. So this is the pattern we are trying to match, and I'm going to just add an R so we can read this in literal terms. All right. Then once that is done, we have our class code. Then we do class code dot match, and then we start grouping. So we are grouping the first match record. So in this case, this is going to be our first matched and the second match in this case. Okay, so this is the second one that we need to get in this case. All right. So we say group 2 if the class code match is there, else none. Then we return class code. All right. Okay, so basically we are matching the class code as a string, and then we are getting the data in here more like this as a decimal. Okay, and that's exactly what we need to do, and that fixes our class code. We are going to take this for a spin and see if we are able to do this or get that as we want. All right, so let's continue with the start date in this case. All right, so we have our start date. We do the same thing. I'll just copy the try except here because the structure is pretty much the same. It's just easier to have a separation of concern. So let's say the open date, which is going to be the start date. So we are going to come in here, open date. All right. So instead of class code, we change this to open date. But the problem now is there are some, I've reviewed the file. There are some file in one of the files, or some of the files are having capital D, small letter D. We need to be able to match those irregular use cases in this case. So we are going to do that by coming back here. I'm matching capital D and small letter D with date. We get that, and we are getting the string, and then we need to get the data in this case. So the date here is number, right? So that's going to be what we are specifying in this case. So we have -d, that's the two numbers. In this case, 0 to something something, then minus -d again. That's the second part of the date, and then finally we get this -d for the third part of the date. That gives us the date. So let's say 0102 1994 or something like that. You get it. You get the point. Okay, that's this date 18. Okay. So then we just get the date. In this case, we have date time, and then we do the stripped time. So strp time. So we can easily convert that to the formats that we want. So in our case, we have open date match dot group. So we are grouping this. So the second group that we want is not the first string. It's not the first string. We are looking at the second group in this case. So which is the group 2, and we are passing that into our the format, which is the month, percentage D and percentage year. Okay, month, day, year. All right, you can change the format if you have a different format in mind. I'll just minimize this a little bit. We have open date underscore match, and then else, if there's no open date, we just return none because we don't need to return anything. So I'll just change this to start date, and this will be start underscore date. Good. So if there's nothing like that, we say error extracting date. All right, start date. Good. And then we do the same thing for the end date as well. So let's quickly do the end date. I think the end date is a little bit tricky in this case, because if you look at the the txt here, you need to look at the end date. This is the application deadline, and you can see from 8 a.m. July 13 here, July. So we're looking at something like this to pick the date here. All right. So that's what we're looking at. So to do that, we can easily do a simple string matching in this case. Let's see the end date. Okay. So we're going to be doing end date match. So this is going to be a long one because we are going to be matching each of the month that we have in here, whether it's January to December. So we're going to have a pattern of January. So the January we have February, we have February, March, April, May, June, July, August, September, October, November, and December. Good. So once we get this, we put this in a bracket. So we get that as a string. Then we start getting the other information that we need, which is the other part of the date. We get the /d for that, and that could be 1 or 2, which could be 1 or 2. So it could be 26 or July 1 or something like this, June 7 or June 2. So it could be 1 or 2 characters. So that's why you have 1 or 2 there. Then we have the string or decimal, and then we have 4 characters in this case. All right. So we are getting the 2019 in this case. All right. So the comma that is here, there's no need for space. So the comma that is here is representing this comma. So we have the string, then the 2 characters, comma, then the 4 characters in this case, which is exactly what we represent in our case here. And where are we passing from? We are passing from file content. Good. And finally, once that is done, we just need to do a match for this. Yeah, I'll just move this to the same line. And we just need to do a match for this. So the end date in this case is going to be the end date match. And then we do a group. So we get the first grouping if there's any end date match. Else we say none. And then we say end date. It's going to be do the same thing as date time, strip time. So I think I'll just copy that. I'll just copy this to the end. I'll paste that here, and I'll just quickly change this to end date because we've already done the matching, and then format this. But in this case, it's not going to be the month, day, and year. So it's going to be the format is going to change to capital B because that's how you represent the wordings for the month in this case. So we have B space percentage D, comma, and then percentage capital year because that's the 4 characters. So you can look up how the date format looks like in the documentation if you want. So if there's end date, do we do the parsing? If not, we say none, and then we return the end date. Okay, I know this might be a lot for some people, but that's how to do the parsing. It's a little bit more complicated than structured format. All right. Now, that's the end date. I think before we continue, let's quickly take this for a spin and see if we're able to correctly pass this data before we continue. So if we have any issue, we quickly catch it head on before we continue into the other parts of the system. All right. So I'll just have my job bulletins DF in there. And I can quickly do the simple parsing in this case. I go have job bulletins DF is going to be job bulletins DF dot with column. The column name is going to be file underscore name, and then I'll do a regexp replace, regexp replace. So the reason for that is because if you can recall in the file name here, let me just finish. I'll show you what I mean. Regexp replace SQL functions. Okay, so I'll be doing a regexp replace for the UDFs that I have, and I'll be extracting extract file name underscore UDF, which is this guy coming from the UDF you choose. Extract file name or position, whichever one that I want to use is the same thing here. Is that it? Define UDF. No, this one is what I'm using here. Extract file name UDF. Okay, then once I get that, what am I passing as an argument into that? I'm passing the column value from if you can recall, that's what the data structure looks like here. This guy, where are you? And this is our batch. I think it's down here. Well, somewhere down here before we did our full parsing. I think you saw it, so I don't want to waste too much time in there. So we got it from there. Okay, so I'm going to be replacing the return carriage. Okay, I'll be returning replacing the return carriage with empty data. Okay, so that would give me access to that. And I think I should just reduce this a little bit. Okay, so I have all of them in a go. Okay, so once the file name is passed, then we have the same thing, job bulletins df. It's going to be job bulletins df with column. Then we pass in the value as well, so we can get in the value. I think we can do the replacement as well for the regexp. So once we extract that, we can always get all of the other regexp replaced. But interestingly, we need to just regexp replace the value. Yeah, I'll get back to that much later because I saw this particular error, but I'll get that to that much later. So let's just continue in this space. And so in our case, not with column, with column. All right. Then let's get in the position. The same thing with here, but the structure is a little bit different now. Job bulletins with column. So we get in position, and we just do simple UDFS, and then we do extract position UDF. And once that is done, outside of the closing brackets, we just get in our value, the column value in there as well. And that's our position. We have the salary start. Yeah, just replicate this salary start, extract salary UDF. I'm passing in the value, but what am I getting afterwards? If you look at the structure here, our salary start for the schema, here we have salary start is inside salary UDF. So once this is passed in, we have two columns in this case with two values. So we need to pass in the salary start from there. So salary, once we do that, we do a get field, and we're getting salary start. Okay, then we do the same thing for, I'll just duplicate this line, and this will be salary end, extra salary, and then we get the salary end. I think, is that it? Okay, we've not even gotten to salary yet, but we have the start date and end date. So just comment this for now. What do we have? We have the date, right? Start date. I thought it's I was thinking it's salary starts in my head. Okay, extract, instead of position, we change that to date, UDF, started, extract date UDF. Yeah, that's it. So we have the value there, and then for the end date, we have the end underscore date and extract end date. I think it's together. Yeah. Extract end date, extract end date underscore UDF. Yeah, they are together. And that's what we need to do to get the UDFS in this case. Okay. So once we get this, we just quickly do a select. So we just do, let's say J underscore DF equals to job bulletins DF dot select, and we get in the file name. We get the position. There's no need for position. They are usually the same thing, but we can get that as well. Maybe position. Do we have that in the schema? Yeah, we do. We have position. What else? We have the start date. Then we have the end date. Okay, I think those are the columns. We don't need the value. It's really useless to us right now. And instead of this, we just do the jdf dot write stream to the output. Okay, so we just do this. We run this and we take a few seconds for it to be done. Yeah, we are not using our Spark cluster right now because of the iterations. I want us to have fast iteration, and that's why I'm using the PySpark on my system just to run it directly. Eventually, we are going to submit this job to the cluster and see how that looks like. Okay. So what do we have here? Do we have any error? So it says function object is not subscriptable. Okay, so let's see what we have. So the UDF, when we're doing UDF extract file name, where are you? This one. So UDFS extract file name, that's the error in there. Apparently I didn't see that. I feel like this is taking much time for the iterations. We have not even reached the AWS yet. So I'll just comment this. I'll just stop this for now. And you can see what the data looks like here. Do we have any issue? Yeah, and you can see what that looks like here. So this is getting everything here, but that's not parsing, is it? Yeah, we have file name, position. So what I'm going to do is I'm going to remove the file name from there, and we just have just position. Let's see. Yeah, I'll just remove the file name from there and then remove the Adobe AWS. In fact, I'll just comment out these guys for now. We don't need them really for now. Yeah. And then just here, instead of the file name, I'll just have extract file name. Yeah, I have this, and I'm extracting the value here. Then I have this as well. I'll just clear this up and go back to the code here. Let's see what we have. So I think in this replacement for the file name, I'll just change this. Instead of just ordinary empty space here, I'll add a space here. Just put a space here and space there. And let's quickly try that out before we continue. It's important we are able to see that before we continue. So let's see if everything is fine. In a sec, it's coming up. And 1, 2, 3, boom. Okay, so let's see. Okay, so we have the file name. What else do we have here? Okay, and it seems like we have file name, start date, end date. So I'll just add a file name here. Just put the file name here, start date, end date. Okay, and the space there. Okay, I'll just run this again, because that's a validation of what we've been doing so far. Until this is done, I don't think it is wise to continue. Okay, just let's double check that. Okay, so let's see what that looks like. And boom. Yeah, file name is fine, but the position wasn't okay. So file name is all right. So we can leave that at that. So instead of position in this case, we use file name. So for the position as well, if you want to use position, we have to do the same thing for position as well. So instead of this, extract position UDF, and that should fix whatever issues that is left with position. So we already have salary start and salary end. So let's uncomment this and fix the implementation for that. So I'll just minimize this and minimize this as well. So we have the salary start and end. So let's quickly fix this. If we go to the implementation here, extract salary, and we go to our code in the df utils, that's where we have our salary. So for us to extract the salary, we are going to extract salary, both the start and the end at the same time. So because they are more like connected. If you look at the data sets we have this, the lower bound and the upper bound, okay? So in our extract salary, we're going to have a try except here, except exception as E as before, and we are going to have salary pattern. So what I'm going to do basically is to represent the salary pattern in form of regular expression. And if you look at what we have here, this is the salary pattern. This is one, but there's another one that I'm going to just try to bring up if I can quickly find something like that. Let's see, one sec. Okay, I have one here. I'll just copy this and show you what that looks like. I'll paste it here in the input text. So if you look at the animal care in this case, so you can see the different variations of this. So we usually want to get the lower bound in this case, which is 65K, and the upper bound is 108K. So that's what we want to really extract in this case. So for us to extract something like this, we need to write a regular expression that can capture something like that. So I'll just quickly, I've written it somewhere. I'll just quickly write that to avoid typos or anything that can delay the code. I'll just write it here and I'll paste it here. So, but basically, this is what it looks like. You have a number which is could be one, between 1 and 3, and comma, something like this. You have two. You can see 2 here. It could be maybe 102,000 and something. So if it is like one between 1 and 3, so it should be maybe 108,000, comma, then the 000 after thousand. This is the D3 here, and then 2 the next 1,000 and something like that. So that's what the representation of this regular expression is really. So salary match, just quickly get the match for that. And the match is going to look like a regular expression of search. And we're searching for the salary pattern and in the file contents. Simple as that. Now, the next thing we want to do is match if there's a salary. If there's a salary, then we get the lower bound and the upper bound, okay? So in this case, we have if salary match. That means we are able to find that particular salary, something like this. We're able to see something like animal care, something like this. We're able to see something like this in the file content, okay? So to get salary start, which is the lower bound, we say salary start equals to, we convert this to float and then do salary matched of group. So we get the first group, and then we do a replacement of the comma. In that case, there's no need for that. Just do replacement for that, and that should fix our issue with the salary match in this case. Okay, so the replacement, why do I have to, yeah, it should just be this. Okay. All right, so that's our salary start. Then the salary end in this case will be something similar, but in the case of adjustment, so we are going to have a different group. So we are going to have group 4 in this case. I'll say group 4, and then we do replacement. So if there's any salary, for the group 4, which is the fourth group, then we are able to get that. But if not, we are going to use the salary too. All right. So what that means is if you pick this guy, so let's say this is the first group, second group, third group, fourth group, fifth group, right? If we are able to find the up to the fourth group, then we pick the last item in this case. If not, we are going to use the second group basically. So we are going to ignore the rest. So that's the safest, okay? But you can use a different logic if you are interested in that. You can, slice and dice the code as you like. But that's the option that I'm more comfortable with in this case. So I'll just do the group 2. All right. So once I do the group 2, I do a replacement. Just like I'm replacing the comma in the 1,000 with the empty data in there. Good. Then finally, if there's none, then there's no match. So we just say salary start, comma, salary end equals to none, comma, none. All right, simple as that. We just do a return salary start and the salary end. All right, so basically just to do a quick recap. So if we're able to find in the long string of text of salary, which is the salary range, we wanted to find the lower bound of the salary and the upper bound. So if you're able to find it, we pick the first and the upper bound and the lower bound. But if we are not able to find that, we just find a minimum bound, which is the first two, the first one to, let's say, 1,000 to 2,000, then 2,000 to 3,000, something like that. So we get 1,000 and 3,000 in this case. So that's what we're trying to do in this case, basically. So once that is done, let's quickly get our exception as E. Then we just do raise value error, and that would be error extracting salary. Okay, and basically we just put this as a string str inside this str of E, basically like that, something like that. Okay, and that is done. So let's quickly pass the requirement as well. I mean, if we run this now, we should be able to see, in this case we need to select this as well, because we've now enabled the salary start and salary end. So we just add salary start and salary end, salary start and salary end. Okay, so if we run this again quickly and see if everything is fine, we just wait a few seconds for the loading to be done. Okay, it's coming up in 1, 2, 3. Good. And if you see what we have here, you can see that for water treatment, we are able to get the salary start, which is 65K, and salary end 108K. And if you look at the what's that? This is the water treatment operator. That's accounting clerk and water treatment operator. Okay, and the minimum in this case is 65,646, and the upper bound is 108,722, something like this. You can see we are able to get this. But in another case, if we are not able to get the last upper bound, we are going to default to the first group of two, right? Which is the first 64K to 81K. All right. Then if you look at the accounting clerk in this case, it's just simple 49K to 7168, which is good. And so yeah, that's basically it. So let's continue parsing. We are getting there gradually. Okay, so now we are able to extract the salary. Let's go for the requirement as well. We have extracted this class code. So let's quickly do the requirement. So I'll just remove this. I'll say try except. Okay, exception as E. In fact, I'll just quickly copy this. I think that is more like repetitive now. Requirements. Okay, simple as that. And to get these requirements, if you look at the positioning of the requirement, let's look at the accounting clerk in this case. So the positioning of the requirement is after duties. And this is the requirement, and it looks like requirement minimum qualification. So in other news, if you look at this guy, requirement minimum qualification is there. But it's also possible to have something like requirements. So that's where you have to go for a very huge sample, just sample here and there to see the different versions. I've already done that in the background, so I realized that some are having requirements and requirements. Okay, the same thing with minimum qualification and minimum qualifications, something like that is happening. So I'll just quickly match that, so just so we don't have to waste too much time verifying things here and there. Okay, so we have requirements match. This is the regular expression for that. We do a regular expression dot search, and we do an literal search. That's the R. Okay, and we have the requirement. So when you see requirement, okay, or S. So if we have a question mark after S, that means that S is negligible in this case. So we are getting the string. Then we have the minimum minimum qualifications. Okay, and of course, S also in this case is negligible. We can have it and we may not have it. So get everything in there up to, once you get that, you get it up to process notes. So if you look at the data we have here, we have it up until process notes. So that's what we're trying to do here. And the S of process notes is also negligible as well. So it could be process note or process notes. Okay, so that's that. And then we have file content. Okay, simple as that. So basically what we're doing is once we get the file content, we also need to get something called read.all. So I know this is a little bit somehow, but if you want to, look at the documentation, it's important to look at that. So if you want to look at the .all, but what this means is basically it gets all of the information. That is, if you have requirement, qualification, regardless of where it is. So if it is replicated a couple of times, it's going to get all of the replications into a single output. Okay. So we have the requirements match, but you can just check the documentation to fast check or to double check what I was saying. Okay. So we do a strip. Basically, if there's any requirements match, else you do none. Basically just return requirements. Simple as that. And now we've extracted our requirements. Let's do the same for notes. Let's quickly do that. I think the video is getting long now, so I don't want us to spend too much because we still have to go to AWS as well. So let's quickly do that. I'll just quickly get this, copy that, paste in here. Instead of here, I'll just change this to notes match. And in our case, we are looking at notes. So if you look at here, we are looking at notes, all these notes. Okay, that's what we're looking at. So we have, I'll just get this. And in this case, we are looking for notes. And of course, S is negligible. It could be notes, it could be notes. All right. So, and once that is done, we get everything in notes dot asterisk. Then we do question mark. If it is applicable, then we have up until duties. All right. So this is heavily regular expression based. I understand and I appreciate that. So just if it takes a couple of times to get that, you might want to just double check here and there. All right. So ignore case is going to match this with small letter notes or duties or not. So if it is capital or small letter, it doesn't really matter in this case. So simple as that. Note is going to be notes match. All right. And then we do a group of 2. We get that and then we strip it up to remove the leading and trailing spaces. All right. So if there's any notes match, else you do none. So, and then we return notes. As simple as that. In this case, we are not using requirements. This is notes. So we do the same thing for duties. Let's quickly copy that for duties as well. And change this from notes to duties. Duties match. And then we are searching for duties in this case, and we just copy everything here up to requirement rec, which is going to be A to Z. And basically what I'm doing basically is if you look at the notes here, we are looking for extra duties. If you look at the duties here, obviously it's not applicable in this case. Is it? Yeah, there is. So we have duties here. So we are getting everything in here, even with notes and all that. We are getting that up to requirements in this case. Okay. So that's what is happening here. So we are getting everything up until requirement. And yeah, that's the pattern. And then we do a file.all. We can ignore case, but I'm going to remove the ignore case in this case. All right. Anything else? We just need to close this square bracket and we should be good. And our regular expression should be able to match anything between A to Z after the REAQ. All right, so once that is done, we have duties, which is going to be duties match dot group of 2. Then we do a strip, just like before. Then if there is any duties match, we match that, else we do none. All right, simple as that. And then we return new duties. Okay, and instead of notes, we say duties. Good. Excuse me. Then we have the selection as well. Let's quickly match the selection. We have about 4 of them left. I'll just quickly rush through them. We have the try except, exception as E, All right. So once we have the exception as E, we do the raise value error as well, just like before here. Yeah, we do that. And instead of that, we say selection. Good. And finally, in the try catch, we do the parsing. Of course, I'll just copy this. All right, and paste it there. We have the selection match, and here we have, just remove this. So we're searching for selection. So, but what we're searching for in this case, if you look at this space, the selection criteria is a little bit it's a little bit tricky in this case, because what we are looking for is multiple choice test, as well as this is 100, which is multiple choice test. But if you look at the animal care, let's say that this one, selection process, you have multiple choice test here as well. But it's possible to have, I think I can find one that is a little bit different. Yeah, I'll just copy this. Let me show you. I'll paste this here. And if you look at the selection process here, it's having written test, essay, interview. So it's a little bit tricky in this case. So we need to be able to parse this correctly. So what we want to do basically is to parse that. And to do the parsing, we just need to get the right, what's the name? The right regular expression to match something like that. I'll just do an A to Z in this case because it's a little bit tricky. So I'll just do A to Z here. And once you get that, get another A to Z, which is maybe small letter characters, okay? And then you find that, and it should be a string, basically. Instead of search, I'll do find all. Okay, I'm searching for A to Z in this case. Then I'm searching for the string. Should be dot, and I'm searching for S as well, plus. Good. Okay, so that should find me that. So what that means is basically I'm looking for anything before this dot, right? Something like that. Something, yeah, this one. I'm looking for something like that before dot. Okay. So I'm looking for anything dot, and I'm picking everything before that. That's basically the interpretation of that. All right. So I'm not searching for all of them, but I'm using the find all selection criteria there. So I'm just going to say I'm using list comprehension here. So if there's a selection match, so because this is going to be a list, so I'm going to be selecting for Z in this. I'll just quickly get the Z0, which is the first element. So it is possible to see something like this and see something like this as well. So we don't need the second one. We need the first one. That's what that means, basically. Get this if there's any selection match, else none. Okay, simple as that. And then we return selection. Okay, if this is your first time with regular expression, I know this might be a lot to take in. Yeah, so just take your time. It's not the end of the world. If you don't get it at once, just try to follow through. You should be able to catch up. Okay, but if you are a little bit experienced with regular expression, it should be fairly easy to catch up. All right, I'll just get this back here. All right. Good. And in my exception here, this is going to be experience length. If I can only type length. All right, so I'm just going to do the same thing, experience length match. So for the regular expression, basically what I'm looking for in the experience length is something like this. I'm looking for something like, where is it? Let's see the minimum qualification here. What am I looking for? So let's look for something else in this case. I think we should have something like that here. Let's see selection process here. Let's look at accounting clerk. Yeah, selection process. So it says we are looking for experience length. So the number of years of experience that you can have. So usually there is a word for each of the years. So it's like 4 years, 3 years, something like that. Where is this? I think not this one. Yeah, something like this. 2 years of full-time paid employment, something like this. So 1 year of something like that. So that's what I'm looking for to match in this case. So I'm trying to do a search. So I'm searching for, just like I search for the January to December. So I'm searching for, in this case, 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10, basically. And then we do the same thing for maybe a small letters. Okay, 1, 2, 3, 4. Yeah, I think that's fine. Maybe 5 as well. It's okay. Any of them. Then we are looking for, after we get that keyword, we are looking for years afterwards. So it could be year or years. So this would be a question mark in that case. So once you find that, we are looking for of. All right. And then afterwards, we're looking for full, maybe with dash or not. So dash backslash S. So it could be full, uh, so it could be full dash time or full time without dash. Okay, if that makes sense. I know this is a little bit somehow, but yeah, that's what I'm looking for in this case. So I'm looking for full time, full time. There's no need for S here. I'm looking for full time, but it could be full dash time or full time. Yeah, I know it sounds somehow, but it's okay. So we're looking for that in this case. So once we find that experience length match that matches maybe 1 year of full time as a word. So in this case, we are looking for, let's say, year of full years, I think. Let's look for years. Yeah, if you look at something like this, so we see 2 years of full-time paid. So this is the keyword that I'm searching for. It could be 1 year, 2 years, 5 years, or something like that. So that's what I'm trying to match in that case. I hope that is clear though. You see, if it is not, well, I don't know, just maybe drop a comment or something like that. So we have experience length match. So we are finding the first group in this case, if there's any experience length match, else not. Okay. Basically afterwards, we just return the experience length. Okay. Yeah, that's interesting. Okay, so let's do the next two and we should be good here. So for education length, I'll do the same thing. It means basically the same thing with the full time as well. So what this means is we're just basically looking for something like that, but we are looking for something around college. Okay, so instead of after the years in this case, I have up to 5, and then I just quickly adjust this part. Excuse me. So I just adjust that part. So it could be a string of S minus. So then we are looking for years. Okay, so it could be 1 to 5 years or something like that. And then after that, we do college. Okay, so if you see college or university, then we should be good. So if you find college or university, university, all right, we should be good. So whether you see university or college, we should be okay. Okay, so we are finding that in the file content, and that should give us what we need basically. And so this is not experience length, it should be education length match. Okay, so I'll just do education length match here, and I'm grouping for the same thing that I'm doing for here. I'll just do education length, and I'll just return that. Yeah, and instead of this, education length. Okay, and finally, application location. So I'll try to just quickly brush through that as well. Except what exception as E. Okay, so I just raise a value error in this case, just like this. Just quickly paste that in. Extract application location. Simple as that. And in the matching, in this case, I'm going to have application location match. So the match in this case is going to be re.search. I'll just quickly do a search. So what I'm searching for is something like this. Applications will only be something like that, something like this. Application will only be accepted online. If you see something like this, then it is online. If not, it is offline. Basically, that's just my criteria. It could be different for you, so I'm just doing that for my own criteria in this case. So just do applications will only be accepted on plus line. Okay, it could be online, it could be on minus. It could be online or online, you know. I hope you get what I mean. Okay, so it could be on dash line or online together. Okay, so then we are going to be ignoring the case. So ignore case. Good. And the same thing, we just say application look equals to online if application look match, else I'll just say mail or in person. Simple as that. Okay. And I just return application location. Simple. Yeah, the typo doesn't match. It doesn't matter in this case. Okay, good. So we're good to go. And is there any other one we've not implemented in this case? I think, yeah, everything is pretty much implemented. So let's go back to our main.py and quickly type in the rest that is missing in this case. So we've handled up until end date. So let's handle the rest. So we have start salary end. We have start date. Let's get in the class code as well. Just duplicate this a couple of times. I have class code. The class code is going to be extracting from the class code UDF, and then for the next one is requirement. Extract requirements. The next one is notes. Duties, if I can still recall correctly, selection, experience underscore length. We have education underscore length as well. And finally, we have application location. Okay, so let's quickly fix the rest. Requirement is fixed. We have the notes. We have the duties. We have the selection. In this case, selection. We have the experience length. Experience length. We do the same for education length as well. Education length. And finally, we have application location. Okay, finally, good. So, so for us to get what we're searching for in this case, I mean, the number of columns that we're looking for. So we have the salary end, we get in this class code as well. Class code. Okay, that's taken care of. We have the requirement, end date is already there. Yeah, we have the requirement, we have the notes, we have the duties, we have selection, we have experience length. Just copy that and paste that there. We have the education length as well. We have the application location. Okay, so it doesn't have to stop here. You can still extract so much more from there, but I'll just quickly cap it there so we don't spend too much time there. Okay, and finally, let's see how that looks like in the terminal when we run it. Okay, I'll just expand this a little bit and in 5, 4, 3, 2, 1. Boom. Okay, so let's see. This is how it looks like. Okay, so not all of them are passing correctly. I think they are. So actually, so what is going on basically is that for each of them, there are multiple lines. So I think that's why the data is a little bit messed up. So I think it's okay if you ask me. This one as well, especially if we just remove all these and all that. But it's fine. We just leave it at that for now. We can always do the replacement much later. But maybe we can just yeah, we can just do that in each of them here. I'll just leave it at that for now. And I think we can proceed. So now we've taken care of txt basically, and I think we can fairly say something here. But if you look at something, just notice something here. We have the airport police lieutenant. If you look at something like this, the airport police lieutenant in this case is not starting at the beginning. But the good thing is we already did a strip in our utils.df. This one we already did a strip, so that clears that out for us. So I just realized that because I had that kind of issue when I was doing some checks and all that. So now let's work with JSON. I have a couple of JSON that I can work with in this case. So I'll just, copy about maybe 5 of them and just paste it in here. In fact, I'll just copy one so we can test properly by the time we are in the, full testing phase. Okay, just one is okay for me. And this is how it looks like. We have something like this, whether utility operator or something like that. So the schema has already been mapped for us. All we have to do is basically join this. So this is like a bonus. We are working with unstructured data, but we still have structured data embedded within the unstructured data space as well. We have structured data and unstructured data that are embedded and intertwined. So if you ask me, I would say most times you want to separate all of this by their extension. So if you have CSV, JPG, something like that, you just put them in separate folders and you process them usually with a similar logic. But in our case, we have structured data and unstructured data. So in this case, I'll just read the JSON and join it with our unstructured data that has been structured with our streams and then write it to AWS. I hope that sounds like a plan. So let's continue. Okay, good. Now that we've handled our stream from here for the txt, let's handle the JSON as well. I think the JSON is a little bit more straightforward. So I'm just going to say JSON df. It's going to be spark.read stream. In this case, I'm not going to be reading from JSON, but the input directory is going to be JSON input directory. And we need to pass in a schema. Unlike when you are reading directly with PySpark, usually you don't pass in the schema or you pass it as an option separately. But in this case, it has to be in the same bracket. I made that mistake and it cost me a couple of minutes. So you don't want to do the same mistake, all right? Okay, so we have a schema in this case and you pass in the schema in there. So we have data schema, which is this same schema that we have here. Once you have your schema, the next thing you want to do is maybe multi-line. So just in case there are multiple lines that are going into all this return carriage and all that is flying around here and there, you want to, excuse me, you want to undo them. I think we can also replace, once we replace this, we can also replace, we can do another regex replace here. Let's do a regex replace. Another regex replace. I'll just copy this. So we can replace all carriage returns as well. DR, okay, \r, and we are replacing that with space as well. Okay. Yeah, just close that up and we should be good. Good. Okay, so that should fix all our carriage return problems because everybody is reading from value, if you notice. Okay, so that should fix our problem then. Good. And JSON is taken care of now. And let's see if we are able to read data from there as well. So what I'm going to do basically is just quickly comment this part out so we can test our JSON. Just what am I doing? What is it? JSON. Yeah, quickly highlight this, click on that, comment it out. And in our JSON, I'll just have, in our JSON df, basically, I'll just do JSON df and I'll select the same thing here. I'll just select everything here. It goes to this. Once I select that, we should be good. And I'll just do this, JSON df dot select, and we should be good. Okay. And once that is done, quickly write that to the terminal and see if everything is fine. if we are good to go, then it's easy for us to have the two streams at the same time. Simple as that. But if not, we have to fix this JSON as well before we proceed to maybe PDF, music or videos or something like that. Okay, we're almost there. We're there. Good. And let's see what we have here. Boom. Everything is fine. Good. So everything is passing correctly as we expected. So this is good. This is fairly straightforward for structured data. It's really not an headache, but it's only unstructured that you have to do regular expressions here and there for matching and all that. So now, interestingly, we now have two systems. Which is our structured data and your structured data. So what I'm going to do is basically just join them together and write them to S3. Okay, so let's do that. So I'll just uncomment this part out. And since we are good with the JSON DF as well, what I'm going to do here, when I have the two selection here, I'm just going to have, I'll just put this as just job bulletin DF and maybe just space here. And what I'm going to do is just have a union data frame. It's going to be our job bulletin DF, then union of JSON DF. Okay, basically that's what I'm going to do there. So I'm just going to union them, just like you're using union in SQL. So now I think it is high time we bring in our AWS. But before we do that, let's quickly test this out and see if everything is working just fine as expected. All right. We're writing union df to our terminal. So let's see if we are able to see all of the records that we are expecting in the terminal, which is in this case going to be 1 for JSON, and then this is 3. We are expecting 4 records in our case. So let's see if we're able to get the 4 before we continue. Okay, and let's see what we have. So we have, let's see, 1. This is 1. And this is it? This is water utility operator. Okay, 1. And this is still water utility operator. That's 1. And this is 2. Airport police lieutenant. That's 2. Accounting clerk is 3. And water treatment operator is 4. Perfect. Perfect. So everything is working just fine. Now we are ready to write to S3 buckets. Let's quickly do that. Okay. Yeah, so we commented at our S3 implementation earlier, so we need to uncomment that for our jazz. So let's bring it back in. And once that is done, we still have CXV, PDF, video, and image. But for now, we are sticking to these two. Let's see. Okay, so let's quickly do that. So what I'm going to do is do a pause and play and put in my AWS config. If you want to see how I got this, you can check the cards here. You'll see the video where we went into details of how to generate access key and secret key. But for now, I'm not going to go into the details of that because it's a little bit time consuming. So, and I'm exposing my secret key and then I have to delete it and recreate it after the video. I don't want to do that. So I'll just put that in the AWS access key and secret key in the background. So you might not see that. So let's continue. Okay. So just get your access key and the secret key and it should be good. Okay. I'll just paste that in here and I'll paste in my secret key as well in there. Okay. Good. And I'll close the config.py up and go back to all of this implementation that we have. Okay. So if I have the main, so in my union, in this case, so what I'm going to do basically is have a stream writer. So you should be familiar with that by now if you have been following our videos, but if not, you should maybe check our videos out. So we have a stream writer where we have an input data frame, in this case of input of data type data frame, and we have our checkpoint folder and the output in this case where the location is going to be on AWS where you are writing to. All right, so let's bring this in. It's coming from we are importing from SQL. Okay, so what that means is we are returning input.write stream. So usually what you do in this case is because we have multiple write streams. So if it is just a single write stream, we don't need a stream writer, to be honest. But if it is multiple write stream, it makes sense to have a single function that you can recall multiple times. Okay. So I'm going to just have In our case, we have a format. In this case, we have format, and we are writing into Parquet format. You can use CSV or any other format, but Parquet is more like is becoming the de facto standard for writing or saving data on your data lake. Okay, so I'll just do that. And basically, the checkpoint location is going to be the checkpoint folder. And in our case, we are going to have another option. The option is going to be the path where the data is going to be sitting in on AWS. Simple as that. Then the output mode, in this case, is going to be append. So you want to be careful whether you're using complete or append. So if the data is not the same, if you're using maybe complete mode, you have to check the properties of your data, whether you have watermarking in there, stuff like that. Okay. So we just have a processing time of 5 seconds. Simple as that. We don't want it to be the latency shouldn't be too late, and it shouldn't be too fast because of the read and write processing. Okay. So I'll just do a start in this case, and then eventually, instead of writing from the query to the terminal here, I'll just say query equals to stream writer, stream writer. Okay, and I'm writing the union data frame in this case, and which S3 bucket location am I writing to? So let's quickly fix that. So I'll just open up my S3 bucket, and I'll be writing into one sec. Let me quickly create a bucket. I'll just bring it here, and I can have a bucket created. So I'll call the name of the bucket. I'll call this Spark AWS Spark Unstructured I'll say Spark Unstructured Schema. Okay, Unstructured streaming. Okay, and copy settings from existing bucket. I'll do that from Spark streaming. Okay, and that was my previous settings, which is fine to expose that. No blocking of public access is fine. Everybody can access it. It's going to be deleted anyway, so it's fine. So I don't need bucket versioning, no encryption, and that's that. I just create a bucket. Any error? So it says there's an so I'll just do Spark Unstructured Screaming. Create the bucket. Okay, the bucket is created. Spark Unstructured Streaming, and I'll just copy the S3 URI. Can I copy that? Yeah, I'll just copy the name and go back to the code here. And in our checkpoint folder, we are going to have S3A, and that will be this Spark Unstructured Streaming. And then we are going to have checkpoints. Okay, and you're going to have maybe Spark. I'll just leave it at checkpoint really, and copy that and duplicate that same for output, which is where the data is going to be sitting in. So in this case, instead of checkpoint, I'll put it as data. So we have a single folder for that, and I'll say Spark Unstructured as the folder name. So all the data that is going to be written to our S3 will be written to this Spark Unstructured folder. Good. And I'm awaiting termination. Eventually, I'm going to be doing Spark.stop. Good. And yeah, that should be fairly easy and straightforward, to be honest. And what I have in here, so that means by the time I run this again, I'm expecting to see 4 distinct records on AWS. So let's test that theory out and take this for a spin to see if everything is working as expected. By the way, I have skipped one step in this case, which is the step where I generated my access key and secret key. Just in case you don't see that, you have to go to your AWS, go to your profile, select credentials, and generate an access key and secret key. If you need help doing that, you can check the previous video, which is already in the description, or in the cast in this video. You will see the link to the video that explains it in detail. So we've spent some time on this video, so I don't want to go into too much of details in that. Okay, so let's run this again and see if we are able to do that. Okay, but before we do that, let's quickly do this. When we fix our cluster, then we start submitting with our cluster. All right. Okay, so this is coming up. And it's writing. Wait, it's not. It's still loading. Oh, by the way, you can check this on the UI to see the progress as well. So, but I'm not interested in that. You can see this is resolving to write stream, and this is the checkpoint location. So it's resolving this to S3 buckets on this. You can see the data source in this case. So it's reading input text from our input, and it's writing it into, it's linking that to our S3 bucket as well, reading this as well. And those are the files that are being read from there. Input text, input JSON, for now. And you can see if you see something like this means that the data is being written to AWS, and this is the schema that is writing on AWS. As simple as that. If I come back in here and I do a refresh, I'm seeing a checkpoint and the data folder, and in my data I see Spark Unstructured, which is where I said the data will be written to. And I don't forget, we have 4 data already, 1, 2, 3, and 4, and you can double check that to see 1, 2, 3, 4 in this case. Okay, so now our Spark streaming has been idle in this case. So that means so far everything is working as expected and everything is just fine. But interestingly, this guy has been idle for a couple of 10 milliseconds, that's 10 seconds basically, and it's reported to us that is idle. So what we want to do is we want to keep pasting data into that, and we want to see if it is going to pick it up as data is coming in. So, and I'll tell you what that use case is going to look like. I'll just copy 5 records for our text. I'll paste it in here, and I'll paste that here. And these are the 5 records. And you will see that this is going to get picked up here. And this is getting written. Right now is writing all of them into our S3 bucket in real time. So we don't have to do anything else. Everything is just running. As we are dropping the file in there, it's picking up. So now the use case for this is as simple as that. So you can have a crawler that is dumping file into a particular location, or somebody that is in somewhere dropping a file in a location for you, and you have a consumer, a Spark streaming consumer, that is listening for events of data that is dropped. Once that is dropped, it could be a zip file, JSON file, whatever it is. You unzip it, you read the file, and then you send it to your locals, your S3 data lake or something like that. That could be a use case, but there could be so many more endless possibilities where you can use it for. All right. Okay, so while that has been processed, let's check this up again. We have 5 additional records. If you refresh this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. So now I'm going to add another 5, but in this case, it's not going to be our it's not going to be our CSV. Sorry, not our text, rather it's going to be JSON. So let's pick our JSON and add that to that. So I'll just add, we have water utility operator, and I'll just copy this and paste this 5 JSON here as well, and I'll paste that in here, and we should see this picking up in a couple of seconds. Excuse me. And that is picking up. Yeah, you see 1 of 5. You can see this. So it's processing 5 new records, and that is in real time. Now imagine when you have multiple workers, it could be way faster than this, and the latency time could be maybe 0.1 milliseconds or 1 milliseconds or something like that. Depending on the compute power you have, you could have faster processing time. That is good. And finally, let's just load this up with a lot of data. So we just see a lot of data on our AWS. So we have 5 records before, and I'll just copy this and paste that in there. So it's a lot of them. It's a whole lot of data sets. So in case you want to use this data set, the data set will be available in the description, and I'll just paste this out, paste that in here. Okay. And it's copying all of them into that. So that will be a whole lot, skip for all, if they are already, the data set is already there. I don't know exactly how long. This is 642, about 642 records in there. So you can see them getting loaded into the system, and you can see it's loading them 600 and something. You can see here 641 in this case. So it's running for 641. One of them has been skipped, and you can see them, in real time. This is beautiful. I love this. So now, while this is going on in the background, now it's time for us to have our crawler so we can make sense of all of this data in real sense. So we have data coming from our JSON as well as CSV. Now you can also do something interesting. You might want to know where the data come from by adding a new column, additional column, to specify maybe it's JSON or text or CSV or image or video or something like that when you are doing your data frame. It's simple as just doing a with column and just passing in your JSON, CSV text or something like that into that particular column, and you can easily identify where the data is coming from. So let's quickly go back to our AWS. And I'm going to just search for, in this case, I'll search for glue. Let's go for glue in this case. So what I have in the crawler, in this case, I have a crawler already, so I'll just leave this here and I'll create a new crawler. Okay, so creating a new crawler, I'll call this Spark Unstructured crawler. Okay, and here we go for there's no data maps to glue tables here, so let's add a data source to that. And in our S3 bucket, I'm going to come in here, browse S3, go into Spark Unstructured Streaming, go into the data section and select this folder as my Spark Unstructured because that is where everything is being stored. Okay, I select that and we should be good. Now crawl all the subfolders. Now, there is a clause in this case. If you call all subfolders, there's a particular folder called Spark metadata. In this case, if you select and you didn't exclude that particular file, it's going to mess up the schema of your system. So what you want to do basically is exclude that particular folder from being written or crawled by your glue table, and you see what I'm talking about when you are doing exclude files matching pattern. So the exclusion of the pattern is going to be _spark metadata. That's one. The interesting thing is it could be in a subfolder or something like that when you are working with a bigger system. So I usually have something like this Spark metadata, just in case it is matching before, and then we have Spark metadata afterwards if you want to ignore everything inside the folder, and then you want to ignore everything like Spark metadata. Okay, you want to ignore everything before and after. It could be added, maybe a UUID is added to that or not. It doesn't really care, you know. So now we have a YAM row. So we don't have any IAM row that is going to be used for this. So let's create one. But if you want to use an existing IAM row, I have one that was created before. So we can just simply create a new one. And in this case, I'll call this Spark Unstructured. Simple as that. Spark Unstructured. And I create that, and that should be selected for us automatically. And in the security, there's no security configuration. We click on next. Then the database we want to have, we don't have anyone, so let's create a new database. I'll call this Spark Unstructured DB. Okay, excuse me. And then we create next. So this is our new DB, and if you come back in here and do a refresh, you should see your Spark Unstructured DB in here. So if you want to have a table prefix, so if you want to have something like TBL underscore something like that, you can do that. I'll just leave that as it is, but you don't have to. It's an optional parameter. I'll leave this as well. There's no need for that. Then the scheduling, if you want to schedule hourly or something like that, it's fine. I'll leave it on demand. There's no need for that. Create crawler. And it takes a few seconds to be done, and I think it is created right now. Let's check our Spark streaming to see if everything is working just as expected. I think so. So let's run the crawler. Okay, so once this is done, the next thing you want to do basically is verify the output of your crawler. So the crawler is currently running, but once it is done, you want to check the DB and you want to check the output of the crawler, whether the tables have been created or if multiple tables were created. In that case, that's not what we want. A single table that warehouses all of this data that we have. That's what we want basically. So it takes a few more seconds to be done. And we just wait a few more seconds. It's about 54 seconds in now. Okay, so the crawler is done now, and you can see the one table changes and 0 partitions, which is good. So let's see what we have in the tables. And in our table, if I do a refresh, you can see we have TBL underscore Spark unstructured. This was from Smart City, which is okay. That's not our DB. This is our DB. All right. To see the table data, you can click here, and this will direct you to Athena, where you can just quickly run the queries against that. Excuse me. And in our case here, we have AWS catalog. We select the right database, and you can see the tables that you have in here. One table is here, which is TBL Spark unstructured, and we can just remove the limit in this case and run. We should be able to see all of them. So we have 656 records, and this is how all the data looks like. Interesting. This is so beautiful, and this is how they all look like. So good. So you can scroll to the left, or to the right rather, and you see everything here. And interestingly, so if you want to have, so you can see the selection criteria. So this has also been passed correctly. We have test interview, something like that. And I think you see something like this, test essay interview. So you can also do that. And interestingly, you see male or person. So when you couldn't find the online, so it's using male or person in this case. So you can also get that. So from, or increase the education length or something like that. So that is basically how to run this. Now, if you want, you can also load this, just like we did in the previous video. You can load this to Redshift, create a Redshift cluster, and connect it to your data catalog on Athena, on Glue rather, data catalog on Glue. Then that gets loaded into your Redshift, and you can connect that with maybe Power BI or whatever to do your preview. So you know the number of applications that have been put out there, the application location, if it is mail or in person, whether you are reading data from CSV or something like that. It could be, the possibility is really endless in this case. But this is where we're going to be putting a stop for this. Now, watch out for the part where we're going to be working with the music, the video. Then we have, what else do we have in this case? We have let's see, we have the input, we have PDF, we have JSON, image, CSV, we have videos as well. So you can, watch out for those videos. If you are interested in them, let me see in the comment section. And also don't forget to join the community where you can influence the next video that is coming up. So if you are interested in that, a tally is coming up shortly where we are going to be asking people to ask to the video or the projects they want to see in the next video that is coming up. Oh, by the way, before we continue, there's a part where we skipped the Docker instance and submitting jobs to the cluster, which I said we are going to be talking about. So let's quickly do that before we round up. All right, I almost forgot. So I'll just stop this. Okay, so what we want to do basically is we want to put everything in our cluster. And in this case, our job cluster is here and it's inside the job. So this is the only thing that is recognized by, yeah, we just remove Bitnami. It's not Bitnamic. I always make that mistake every time. Okay, so our cluster is fine now. And what we want to do basically is we want to link the inputs as well. So in this case, we are going to have inputs, and that is going to be linking to, input. Okay, and we can copy this and replicate that for the master as well. So the master is aware of the data. So we need the config as well. So, but I think the config will change. We are going to move this into jobs because that's where we need it basically. And but if you want to make it a little bit less complicated, you can move everything into jobs. So it's easy to track. In that case, I'll just move this and my UDF you choose. So we just have a single folder that is being tracked across board. Okay. So we can do this, and once that is done, that should be synchronizing to our, yeah. In our case, we just submit this. So let's do Docker compose up in detach mode, and we should, in fact, before that, I'll just remove two clusters from here, comment them out. So we just have two clusters in this case and start them up. I don't want my compute to be affected. That's why I commented out. If you have enough compute, you can do that. Okay. So that is done. I think our server cluster is coming up. So we have one master and two workers in this case. And you can preview that in the 9090. If you click on the 9090, that should give you access to the Spark cluster in this case. You see there are two clusters in our case that are alive and they are not in use right now. So let's see if we can quickly submit a job to this cluster. Okay. Let's see what is going on in this case. So we have our main.py. So basically we just do docker exec, and in our case, we don't need the SQL Kafka. So I'll just remove the SQL Kafka in here. So we have packages, and the Spark master is the Spark master 7077, and we are executing into our Spark master in this case. So we have a Spark master, and I'll just what's the name again? I can get that by going into a new docker ps. If I do docker ps, I can get the name. This is the master, this is worker. So I think you can use any of them, to be frank. So I will just copy the master in this case, and that would replace this AWS Spark Unstructured Spark Master 1, and submitting with Adobe AWS and AWS Java SDK. But in this case, I'm submitting jobs main.py, not Smart City or Spark City. So I'm submitting main.py. All right. So if I submit this, okay, something is wrong. So it says it couldn't recognize something. So what was that? Unrecognized packages. Yeah, I think there's a typo there. So it should be packages, then space. All right. And that should be fine now. Yep, I think it is. So it's resolving the dependencies and everything is running. But let's see in our main.py. Has anything changed? Okay, nothing is changing. Good. Okay, so I think we should check now. I don't think it has been submitted yet. So I think it's still maybe compiling the Java dependencies. Yeah, it's downloading them as suspected. Good. So if all of these are successfully downloaded, it should be fairly easy to submit subsequently. So this is the first time. So it is expected that all the jars and all that will be used for the submission will be downloaded. But in this case, there's really not so much. So it's just the Java SDK and the Hadoop AWS that will be used. And I think the Duke on comments, yeah, I think, yeah, it's good. We already did that. That's good. So we have these two taken care of. So we have about 4 left. So let me know in the comment section if you would like us to tackle that particular video. All right. This 4 in another video. Okay. Okay, the download is done. I think it's copying now. Good. I think it's now submitting the jobs. Oh, by the way, one thing that we need to do is clear up our AWS data. So we come back to where is our this is our database. I'll just go to S3 in this case, S3, and I'll delete. Okay, and Spark Unstructured, I'll just have this. As it started submitting, yeah, it's about to. So what I'm going to do is delete these two, and I'll just quickly delete them before they start to write into. Yeah. It says path does not exist. Yeah, of course. So we have to change that to permanently delete. Okay, then delete objects. So we don't need them basically. So what I want to do is I need to change the path from that to a more not the full path, but in this case, it's going to be input. So it's going to be /input. So I'll just remove all of this. And yeah, I'll just remove them because that's what is synchronized into our Docker container. So so I'll just put this here as input. So it's not a full path. So like this. I think this should be fairly straightforward. Is there any other path that we have that we need to pass into that? Any other place that we're using that? No. Yeah, that should be good. And we should resubmit. If we resubmit, let's check our UI to see what we have in our cluster. Okay, if I do a refresh here, we should see our failed job. Yeah, this failed. Well, it's finished, but technically it failed. So it's not the ideal submission, really. So we just wait a few more seconds for that to be done, and we resubmit that. Okay, so it says there's an error in here. So I think what I'm going to do is I'm just going to copy this. That will be the root directory for that. I'll just copy that. And so it couldn't find that. So it's trying to load the text directory, and that's where the issue is coming from. So let's fix that. So let's use the full path. Okay. Jobs input, and that will be the full path. Just copy that. We paste it here. I think those are the two. We don't really need the rest for now. And if you check the UI, Spark UI here to see what's going on, if you do a refresh, we should be able to see the cores that are being used up. I think the reason why this is slowing down is because I'm running everything on my local system. That's why. So you can see this is still running, but I think you get the point. So usually this is dependent on the compute power that you have on your machine. I'm running several other processes in the background, and that's why the system's a little bit slow. But in some cases, when I'm not running anything, it should be way faster than this. So just try to understand. In this case, the jobs are being submitted from our Spark cluster to AWS. Is no longer on my system. So by the time right now is writing, you can see them writing to our AWS. So it's doing some process called here and writing to our AWS system. So basically, all these things are being done by a task manager and the executor. So all these things are being done in the background. And I think if you check our S3 buckets now, we should be able to see the latest data. This is 53 objects, isn't it? If you do a refresh now, we should see the new data coming in. You can see, and if you check data, yeah, my system is slowing down. Oh, no way. If I click on data and Spark Unstructured, you should see them. Okay, they're still loading. I don't think they have been uploaded yet, so we just wait a few more seconds for them to start showing. Yeah, I think it's doing push filters here and there, and it's starting task. So it has submitted them to the cluster, and to the executor is picking them up, and the partition process local and all that. Good. So it's I think it's running them now, but for some reasons it failed. Hey, what is going on here? So it says read UDFs. So that's when the worker was trying to process that. It says no module name, UDF utils. Right. So he couldn't find the UDF utils in this case. So basically, to prevent all these things, I'll just quickly copy this to our main.py. Just paste it here, and everything should be in the same directory. Okay. Well, while I can quickly debug that, well, I'll just quickly save time and save the debugging time without doing that. So yeah, everything should be good. We just wait a few seconds for the synchronization to be complete with our cluster, and we can resubmit on. Yeah, I think the synchronization should be done by now. And I thought, So it just wrote the write ahead log for our Spark metadata and the checkpoint. But when it was trying to write the data, I couldn't find UDF utils where it is going to use the utils that we created for several those several functions that is going to be passing the unstructured data for us. It couldn't read that. So I just quickly copied that into my main.py. Easily we can add an init file to debug that. But I don't know if that is going to work the first go, and I don't want to, keep debugging that and keep things in the loop. So we just wait a few more seconds for that to be done. And you can see the data is being read here, which is good. So it's listing the leave and directories in this case. So it's seeing 650 path and them, and all of them are here, which is good. So you can see them here being written directly from there. That is good. So that means it's going to, it has recognized them. But the next thing is if our UDF utils, we're no longer using that. So it should be fairly straightforward and simple now. So I think this is partitioning them into the separate clusters. So the partition that is going to be running each of the clusters, each of the tasks are going to know them. And I think it's doing some assignment of executors as well to each of the partition. So it's distributing them evenly across board. So in our case, we just have 2 executors. And if you notice, we have 0, 1, 1. And this means that 6, in this case, this when it's sharing them, is distributing between 0 and 1 executor. All right, so that's the 2 executors that we have. So the job should be fairly straightforward and simple. And that's the good thing about Apache Spark, really. So what if we have 4 executors in our case, of 4 workers? So that means it's going to be sharing across 4 executors in this case, so 4 workers to submit the jobs to our cluster, which is good. And to handle them, I guess we just wait a few more seconds for that to be done. I'm really interested in seeing the output of this. Okay. So it's writing atomically. So I think with this writing atomically is writing already. So the Spark metadata has started writing the files, and you can see all of this, which is good. That means data is being written directly to AWS. When I see this JSON, it's a good output, which is the sink. You can see the sink here. That's the output, and the source. This is the source. All right. And that's the sink, which is good. So we can just I think we can refresh and we'll see the data in our S3. Boom! Lovely. And you can see them sitting there pretty nicely as expected. Good. They're still coming in though, but it's still not done. Yeah, it's still coming in. But I think all of them are finished processing. Yeah. This is 25 records. Maybe we just wait a few more seconds, unless everything is being merged into multiple package files in this case. So you can see part 00, part 1, part 2, or something like that. I think maybe all of them have been partitioned in that case. But regardless of that, so let's see if our crawler picks it up again. I'll just delete this and rerun that again. So let's rerun the crawler again. If we're able to see how many records, if you're able to see 656 records, then we should be good. And let's go to our crawler. Where is our crawler? Crawlers. And we'll run this again. Spark Unstructured, run. Okay, waiting for a few more seconds for that to be done. I think it takes about a minute or so. All right, so if you click on this, you should see that in here. So that took 1 minute, exactly 1 minute. So it created a table, 0 partition changes, and the table is this table TBL Spark Unstructured. Okay. We just wait a few more seconds, about 40 seconds or thereabout. 32, yeah, about 20 seconds now. Finally, 2 minutes 25 seconds. Good. So let's go to our tables. How many records do we have in our tables now? I'll just refresh this and you should see it here. And if you check the tables again, I'll just go to query here and do a refresh. Spark Unstructured still remains the same. And let's just run this again. Beautiful. So right now we have 656 records in our table. As expected, everything is fine as expected. Beautiful. So yeah, so I think everything is okay. So yeah, that validates our data and our output is fine as expected. So the next thing is just to maybe load it to Redshift, like I mentioned before, and connect it to something like Power BI, Tableau, or any other UI that you want to use. So you can also use something like Plotly for the dashboarding if you want, if you are interested in the coding parts. So but that's basically it. So if you watch this until this point and you have not subscribed to the channel, please click on the subscribe button, like and share this video with your friends and colleagues. Share it on your timeline, tag me, and I'll be more than happy to retweet that. And if you are able to maybe replicate this same process, don't forget to tag me on all social media platforms. I'll be more than happy to respond to you, gives you a thumbs up, retweet your project on LinkedIn, retweet it or something like that, comments and stuff like that, and interact with it. So thank you very much for watching, and I'll see you in the next video. Cheers.